Hello, Mr. Meneses. Welcome to the most amazing learning experience you will ever have in your life. Give me a second so I can draw the process, right? Okay. What are the parent functions? You might be asking yourself, what in the world does a parent function even mean? I mean, do the functions have parents? How do they do that biologically? Well, the answer is it's math, okay? And also, the parent functions basically means that out of the different functions and the different families of the functions, they're the simplest form, the original form that we base everything off of. Like, for example, we have just f of x. Okay, let me type it out. X. Or we have 1 over x. Oh wait, no, that's a question mark. 1 over x. Now let's get rid of that. Boom, we're back. Okay. Boom. Why? We got all the functions. We got the linear function. The domain and range are simple. For both, it's negative infinity to positive infinity. I'm gonna put that on the screen in a second here. Boom, boom, boom. Explosions, fireworks. Then we have the quadratic function. Now, that one has the domain from negative infinity to positive infinity, but since it starts from a point and then goes up with the range, it starts from 0 but goes to positive infinity. Then we have the cubic function. Basically the same domain and range as the linear function. It just has a weird curve. And then the sine function. Sine and cosine. Basically the same thing, except they look different sometimes. So basically the domain is always just negative infinity to positive infinity. Unless there's, limitations. But then the range, that's where it gets interesting. The base function, the parent function, is like -1 to 1, but sometimes it changes and it's different, right? And then we have the rational function. Now, this is interesting because it never gets to 0, right? So the domain and the range both have an asymptote, right? So the domain on the parent function would be negative infinity to 0, and then you put the little u, like the connection thing, and then you go 0 to infinity, to positive infinity, and then you do the same for the range, and that's it. That's all there is to it. And then a little fun fact in the last two: the exponential and logarithmic function. Did you know that the exponential function is actually the inverse of the logarithmic function? Well, that was a trick question. It's actually the other way around. The logarithmic function is the inverse of the exponential function. Well, the domain and the range. Well, obviously, we can see here that the domain on the exponential function is negative infinity to infinity, but the range has an asymptote. So it might say 0, but it's actually only approaching 0, and then it goes to positive infinity. That is on the parent function. And then the same goes for the logarithmic function, except it's the inverse. So what applies to the range applies to the domain. So the domain only ever approaches 0, but doesn't actually touch it. And then on the other end, it goes to the positive infinity direction. Back at it. Transformations. Now, the same way the Transformers are an easily digestible and very watchable and fun movie, transformations go the same. Except sometimes they get a little complicated because of fractions and stuff. But for the most part, pretty easy. Change of plans, we're using Desmos. Okay, so we have our parent function called f of x. Why is it a capital F? No. Now, you can see that it's a linear function. It crosses through these things like linearly. But, big but here. If we do plus 2, what happened? It went to the left. Why is that? Because when you set that function equal to 0, it gives you -2, which indicates that the transformation made it go to the left 2 units. Now, that's the linear function. Now, if we go here, and then I don't know how to type the thingy, we get x squared, right? Okay. We have x squared. Obviously, we've seen this a lot before, especially in Algebra 2, you know. Pretty familiar with this. But then, what happened? Why am I going to the left? Boom! What did I do? I compressed it horizontally. How did we do that? We set the thingy right there. Boom. Right next to the x, which compresses it. But if I do 1 half, I expanded it horizontally. Alright, then we have the one and only cubic function. Now, another great example would be the other direction. -3. Boom! What happened? It went down 3. You might be asking yourself, why did the other one go to the left and this one go down? That's because we're not putting it within this function. We're putting it outside. So, if I were to go in here, and I were to put boom, and then boom, and then I did it -3, boom. See that? It went to the right. Good stuff here. Good stuff. Then we have the... give me a second. Sine x. Oh, okay, that works. Okay, so sine x. This one's a little more tricky. This one's a little more complicated, but nevertheless, it's still a function. So, all the same properties still apply, just in a different way. So here, we can see that, boom, vertically, it changed. We expanded it by 2, and then here, it works the other way around. Boom, if I do half of sine of x, it compresses. It's different. And then right here, boom, boom. That, and then that. Might not look like anything happened, but look at that. It went back. Okay, I got it. And then pretty much the same goes for cosine. Same thing. Just wonderful. I love cosine and sine. They're just so cool because they're like twins, but they're not the same, you know. And then the rational function. Here we have the big kahuna. The mother of all things, man. This is like... This one's hard. But, nevertheless, this is why we have Mr. Meneses to explain everything. So, what I understood from the class is, boom, +3. Outside of it, easy. That means it goes up and down. Boom, boom. Come on. No brainer. And then right here, you're just changing like the vertical asymptote location. You know? It's just boom, it goes from 0 to -2. Easy. And then right here, you're just changing how like expanded it is. You're like decompressing it. Easy stuff. No big deal. That right there, ladies and gentlemen, is the logarithmic function. What happens here is it gets pretty complicated. This is the, wait. X plus 2. Yeah, that is where you change the asymptote location. Heavy stuff here, guys. Heavy stuff. But it's okay. That's why we have Mr. Meneses to explain everything. Wait. 4, 5, 7. Yeah, that's where you change the thingy. Alright. And then the same goes here. Boom. Stretching or whatever. Easy stuff. And then the same goes for the logarithmic fraction inverse. Not to worry, Mr. Meneses. I got it working. No, I could. Then we have this. It's literally just the same. It's just inverse. Boom. That's it. Thank you very much for watching, Mr. Meneses. Have a wonderful day.